Okay, this is the lecture video for MAT1100. We're in section 2.3 where we're going to be taking a look at area and volume. Wanted to mention that with regard to units, that area is a two-dimensional concept. So when you report the units on your answer, they will have a 2. So for instance, let's say you have a problem with inches, it would be inches to the second degree, feet to the second degree, centimeter to the second degree. Okay, two-dimensional, therefore you will have a power of 2 on your units, whatever the units happen to be in that particular problem. Volume, on the other hand, is three-dimensional, and so all your units will have a 3 as a power. Okay, so just a little bit about that, because you do get points also for being able to report your units properly. Okay, I've provided you in this section with all the area and volume formulas that you're going to need. And basically each one of those is just a recipe that you're going to follow in order to get the area or volume answer. When you're doing perimeter, I mean, there's really no point in memorizing the formulas because you're just adding all the sides, except when you get to a circle. A circle doesn't have distinct sides, it's just one continuous side for that. So for that one, doing the perimeter, or what is called actually the circumference, but synonymous to the perimeter, you will need a formula for a circle. So we'll visit that when we get to that problem. Okay, let's start trying to take a opportunity to use these area and volume formulas. So in the first picture you see a triangle. It has a base, that's called the base, coming across the bottom, and the height that comes down to meet it is also shown inside of the triangle. So I've put some numbers there for you so we can practice using this formula for area. Okay, so we have a 12 here, and I'm showing that the height, I didn't have time, I didn't have room actually to fit it in there, so that height is 4.5 inches, and we're going to use it over here. I'm using it in this exact formula right here, base times height divided by 2. There's my base, there's my height divided by 2, and you can just do these in your calculator. So if we were to continue here, I'll just demonstrate. At least show what you're plugging in, and then you can go, right into the answer. Okay, so in this particular one, it's 12 times 4.5. Always do the top first. You're multiplying what's on the top, and that would be 54. Then don't forget you have a divisor of 2. So divided by 2, you get 27. So this is 27. Inches times inches, don't forget, it's a two-dimensional concept, and that 2 goes on the units, not on the actual numeric value that you got. So that's the answer there. Okay, parallelogram, here's one down below, and in this parallelogram, these are actually all parallelograms, this, and this. And so you're going to be using base times height for the area of any parallelogram. So notice it's base times height for the area of this parallelogram, likewise for this one. Length and width is the same thing as base times height. Length times length, they're only calling it length times length because it's a square, but that is the same thing as base times height. So you're using the same actual formula for all of these parallelograms in order to find the area. So let's say that I give you a 10 right here, 10 centimeters, and then maybe the height is 3 centimeters. So just area for a parallelogram would just be base times height. I'm following that formula right there for area. So that would be 10 centimeters times 3 centimeters. And that would be equal to 30 centimeters squared. Okay, for all of these, it would basically be the same. I'll jump down to the square. area would just be whatever the length is given. It doesn't matter which side they give you because all four of them are the same. So let's say that I give you 7 feet. And if that be the case, it would just be 7 feet squared, or you could go base times height, because if this is 7 feet, this would be 7 feet as well. So you could just go base times height, or because these are equal, that's the same thing as squaring something. So you can write it like this as they've given you right here. Okay, so this would be 49 feet squared. It would be 7 squared, which is 7 times 7, not 14. Remember, when you're putting that in your calculator, if you don't know what 7 squared is, you're using the power key. Okay, so it would be 7 raised to a power of 2, and that's how you get the 49. Okay, it does not mean 7 times 2. So this is going to be 49, 7 squared, or 49 feet squared for your final answer. Okay, and likewise, all of these parallelograms use the base times height formula. Okay, so let's see. I'll do one more. I'll do this rhombus, but it is pretty much the same thing. I'm going to give you a height here of 2 inches, and then this base, I'll give you 6 inches. Okay, so the area for this rhombus would be just base times height. So this would be the base, the 6 inches, and the height would be 2 inches. To give you 12 inches squared. Okay, and if you were going to do something like perimeter, let's say you had a triangle and you have 10 inches here and 4 inches here and 4 inches here. And I was going to ask you to do perimeter. You really don't need a formula because you can just add all of the sides up. You can just go 4 inches plus 4 more inches plus 10 inches, where you're adding all of these up. So in the end, you get 18 inches. When you're doing perimeter, that is a one-dimensional concept. So whenever you're doing perimeter, you have a power of 1, which is the reason why you do not need to put any power at all, because when there's no power here, it is said to be a 1. Okay, so perimeter, make sure you understand perimeter is one-dimensional, area is two-dimensional, volume's three-dimensional. Okay, and that's how you will handle that. Let's move down to trapezoid, and we can take a look at that formula, a little tiny bit more involved. You're going to be adding the bases together first, that's why it's in parentheses, then multiplying by whatever the height is, and then dividing by 2. So in this particular problem, this big B is one of the bases, this is the other base. So let's say that this is, let's see, we'll say that this is 12 centimeters. Let's say that this is 8 centimeters, and then we'll say that the height is 4. Okay, so if you were going to use these numbers in this formula, just a demonstration of how to use those, it would be area of the trapezoid. Follow this exact formula. Add your two bases together first. So it would be 12 plus 8. Add those. Then we're going to multiply that by whatever the height is, which is 4 centimeters. Then we're going to divide by 2. Okay, so in that particular case, it would be 12 plus 8 is 20. And then I would add those two together. First, you have to add those two together first, then multiply it by the 4, because you always want to do your entire numerator first. Times 4, you get 80, and then you're dividing by 2. Okay, so I'm even going to put the units here. Let's see if I can put it down below, because I'm running out of room here. So I'm going to show you each step. So it was 20 centimeters that I got in the first parenthesis. 12 centimeters plus 8 centimeters is 20 centimeters. Then I'm multiplying it by 4 centimeters. And then I'm dividing it by 2, just in case you need to follow this, lady. So it's 8 centimeters times centimeters is centimeters squared divided by 2. So finally the answer is 40 centimeters squared for the area of this trapezoid. Okay, let's also try a circle. The formula for area of a circle is pi times r squared. Sometimes they're going to ask you to use 3.14 for pi, and sometimes they'll allow you to use the value generated by your calculator. So then you'll just touch the pi key. And sometimes you won't be doing either. You won't be converting it to a decimal. Instead, you'll be giving an exact answer. And I'll demonstrate that when we get to the next page, because I believe there's a circle problem there. So I can do area and circumference there as a demonstration of these formulas. Circumference is like perimeter, where you're going around one continuous, not really an edge, you're going around the entire rim of the circle. Area is what you see inside, but I'm going to demonstrate that when I get to the next page. So I just wanted you to take a look at doing various area problems in this section. We're also going to be doing some volume. You can see some three-dimensional objects or shapes right down here in the volume box. We can do the volume of a sphere. We'll be using 4/3 times pi times r cubed. The volume of a pyramid, anything that you could fill up with water or fill up with air, those contain volume, because not only are you multiplying base times height, let's say let's say the base had a shape where you could do the area of the base. You're actually taking the area of the base when you're doing volume and then multiplying it by the height. So you're bringing in a third dimension. And so these are all things that you can fill with either water or air or, you know, things that are similar to that. So we have volume here for a cube is just whatever the side is, because the sides here are A, and you can't see that very well, but I'll blow it up a little bit. See that each side is called A, so when you want to do the volume, it's just A cubed. This is a rectangular prism because the base is shaped like a rectangle. The base is always matched, so if the top here is a square, then the bottom that you can't see because it's sitting on it is also a square. Likewise here, top is a rectangle, and so is the bottom that you can't see because it's sitting on it. So they would have the same shape. So this is a rectangular prism because the bases are rectangular. This is a cube because the bottom and the top and the bottom are both squares. This is a cone. Bottom is a circle. And this would be the formula for volume of a cone. Here for the volume of a cone, it would just be 1/3 times pi times r squared times h. So these are things that you may want to put on your formula card because there's a lot of formulas for area and volume. I'm going to bring this back down a little bit so we can see the rest of the page. Okay, so let's go to the next page where we're looking at circles. Okay, so in circles, We have one here where we have a radius. Radius is from the center of the circle out to the edge. When they give you it all the way across, it's the diameter. So here they want you to find the exact area, and then they want you to find the exact circumference. Then you're going to approximate those answers by turning it into a decimal, namely the pi value, and rounding it off. Okay, so here are exact answers. Exact answers is when there's no decimals have been rounded. In other words, you will not be using decimals. It means you're going to leave the pi in your answer. Don't press it into the calculator. Okay, so like for instance, in this particular problem where they've given you the R value, okay, let's give that a shot. From the previous page, I'll just show it to you one more time. This is area, pi r squared. And this is circumference, 2 pi r. You can also go pi times diameter. That's equivalent to this. So I would just suggest if they give you the radius, use this, 2 pi r. And if they happen to give you a diameter rather than a radius, then use pi times d. Notice that both of these formulas have pi in it. So when they say give an exact answer, you're going to leave the pi actually in the final answer for this or this, depending on which one you're doing. Okay, so for this particular problem, first thing we're going to do is the exact area. That formula is pi. Let's write the formula first. Always write the formula first when you're doing area or volume, just to get yourself centered and focused as to what you need to go and grab off the picture to plug in the formula. So pi r squared is the formula. So leaving the pi and not putting a decimal in it, that's what it means to give an exact answer. And then just take the radius, which happens to be 4 millimeters, and square it. Okay, so what you're going to do is square this number, and you're going to square the units. So it's going to be 16 from squaring that. Then you're going to list the other thing that represents a number, because you list all your numbers first and your units at the end. That's why I'm doing it in this order. So if you have a regular number rather than a symbol, it is agreed upon in all math books that this numeric value will go first, then any symbols that represent numbers, and then the units. So that's your answer. And I did not, go into my calculator and go 16 times pi. Never did that. That's called giving an exact answer. So that's the area. Circumference, on the other hand, has a different formula. It is 2 pi r, just taking these formulas from the previous pages. So this would be, their circumference is 2 times pi times the radius. And again, the radius is 4 millimeters. And in this case, we get the answer. Okay, again, we're going to give the answer just like this. We're going to give the numeric value first. 2 times 4 is 8. Then we're going to give the next value that is represented as a symbol, but is really a number. And then we're going to give millimeters. Notice that I didn't do any kind of squaring in this particular problem. This formula has squaring in it. This one doesn't, and that's why the units are first degree. Again, like I mentioned on the previous page, circumference is like perimeter. All perimeter answers have units to the first degree, and that's why you don't see a power on them. Okay, this is called giving an exact answer. Now, if I want to give an answer where I'm rounding off, then I do have to hit the pi symbol in order to bring the decimal into the problem so that I then have something to round off. Approximating means that you're going to be rounding. And you will round to whatever they tell you to round to. Like for instance, this one says round your answers to the nearest hundred. So if you want to get an approximate area from an exact area that you just found, then you just put into the calculator, press that actual pi symbol, and then press. And you can do it exactly like you have it right here. Let's just do it the way we have right here. We can just press in the calculator 16 times pi. The units, we already know that the units are going to be millimeters squared. So putting this into the calculator, we have 16. Oops, I got to turn it on. 16 times, and then I'm pushing the pi symbol. So for me, it's a second function. My pi symbol is right there under the clear button, but it's in a different color. It's in orange, so I'm going to go like that. Grab that pi symbol, press enter. They've asked that you round to the hundredths place. This is the tenths place, hundredths place. So you're trying to decide whether that 6 should be rounded up or left the same. But because there's a 5 next to it, we round it up. So 50.27. Okay, so this is called an approximate answer, and this is called the exact answer, what we had right there. Okay, 1 second. Okay, moving to the approximate circumference. So exact and approximate. Then we had also gotten an exact answer for circumference, and I'm just going to work right off of that answer. If I want to get an approximate answer, then I just go into my calculator, write from my exact answer, and press in what I got for my exact answer. Of course, not including the units, because the units you just tack onto the answer. So this was millimeters. Again, I'm going to want to round to the hundredths place, so I'm just going to press in 8 times pi. Okay, so just 8 times second function pi, press enter. Rounding to the hundredths place, that would be 25.13. Okay, so a little bit of experience with reporting an approximate answer and an exact answer. Do your exact answer first and then work right from that to get the approximate answer by just pressing this in, just pressing in 8 times pi. Here we pressed in 16 times pi. Again, notice the units are second degree for area, first degree for anything associated with perimeter. Circumference is like perimeter. Okay, moving to something three-dimensional and using those formulas. So for any of this, you're just using, like I mentioned earlier, a recipe for getting either area or formula. You do exactly what the recipe says. So for the approximate volume, let's see, consider the sphere using approximate the volume. So you're always going to just start with the formula. The formula, let me refresh you right here. Here it is right here. For a volume, it's 4/3 times pi times r cubed. Okay, so volume is, let's start off with the formula, 4/3 times pi times r cubed. Okay, let's plug right into that. We have a top where the 4 is, the pi is at the top, and so is the r cubed. So you can extend this bar all the way across if you want. The only divisor you have is the 3. The r in this case, notice that they have given you diameter here. So if you need radius, because that's what the formula requires, then you need to know that radius is half of the diameter. So if you want a real easy way to put that in the calculator, you could do 11.6 divided by 2, or if you want to, you can just do 0.5, that's 1/2 of 11.6. It's up to you how you want to press it in. There's two ways to press it in. You can go 1 times 11.6, which is 11.6 divided by 2, or you can just go 0.5 times 11.6. You're going to get the same answer either way, but we do need that radius, so I'm going to go 0.5 times 11.6, and there's my radius. Okay, so my radius is 5.8 millimeters. Okay, so 5.8 millimeters, and I'm going to dump that right in here to finish my volume answer. Don't forget, this formula has a cube on it, and that's an easy mistake to make. So careful that you're always looking at the formula as you plug in so you can help yourself concentrate. So on the top, we're going to go 4 times pi times 4, 5.8 cubed, making sure that we know how to use our power key. Then once we get this answer at the top, we're going to divide by 3. Okay, so 4. Now, since we're rounding is the same thing as approximating, and it even says that round, it says round here. Oops, this says do not round in the intermediate steps. I shouldn't be doing it there. So do not round in the intermediate steps. Okay, so let's make sure you understand what that means. When it says do not round in the intermediate steps, that means only round at the end. Don't round anything else off except your final answer. And let me even put some more detail on that. Remember when I was finding the radius right here? Notice that I did not cut this off and call it 6 or anything like that. So they're saying do not round at each stage. Round only one time, and that will be at the end. So I did not round that. That's what it means, do not round at the intermediate steps. And then you can round at the end. Okay, so I haven't done any rounding yet. I'm going to press all this into the calculator. So it's 4 times second function, and let's see if they said to use, it says use the pi button, so I can actually touch the pi button, because sometimes the directions will say for pi, use 3.14 for pi. I mean, I even think that there's a problem on the test that's like that, but this one says use the pi key. Okay, so second function pi, we got that. And then we're also doing 5.8 cubed. That does not mean 5.8 times 3. So you got to use the power key. So it's times, you can go 5.8 raised up to a power of 3. Okay, there's my top, 2451, all this. I'm not rounding anything off. I'm leaving the whole thing in my calculator. Then last step is for me to divide by 3. So divided by 3, and I get 817. I'm going to round this to the nearest hundredth place as the directions indicated, so that would be 817.28. 817.28. The units are millimeters cubed as stated on the previous page. Volume is 3-dimensional, so those units will have a power of 3. Do not put this power on the number because it would be a much more gigantic number. This is the actual numeric value, and then it's units cubed. Okay, and that is it for section 2.3.